Hello my friends, alright, let's see if you got this right. So I asked you at the end of the previous tutorial to implement yourself the data preprocessing phase for this logistic regression model, and now we're about to implement that solution together. Alright, so what did we have to do? Well, the first natural step was to go to our data preprocessing template to grab all the essential tools, which are indeed, well, the first steps of the data preprocessing phase. So let's do this. That's the first thing you were supposed to do. So I'm copying this cell and then I'm pasting it right here in a new code cell for importing the libraries. There we go. First step done. Now to import the dataset, well, same, let's go to our data preprocessing template, which indeed is meant for us to be efficient. So I'm copying this and then we'll see what we have to replace. But once again, it is supposed to help you so that you don't have to do much. All right, so just pasted it. And let's do, just this for the last step of the data preprocessing phase, in any situation, regardless of whether or not is needed feature scaling. All right, so let's take that cell here and let's copy that right here in a new code cell. All right, so that's the first essential steps, which happen most of the time when building a machine learning model. All right, so now next step, what do we have to change inside this data preprocessing phase? Well, let's take it step by step. First step, of course, we don't have anything to change. Now let's see second step. Well, there you go. Of course, here we have to change the name of the dataset. It is not data.csv, but it is now social network ads.csv. So let's do this. Let's just replace this. That was what you had to do next. Social network underscore ads.csv. And now, next question, do we have to change anything here? Well, of course, the answer is no. No, because this data preprocessing template was meant for you to not have to change anything in most situations, as long as, of course, you make sure that in your dataset, you have the features in the first columns, these are the two features here, and the dependent variable in the last column. And since this automatically selects all the columns except the last one, and this automatically selects the last column, and this of course regardless of the number of features you have in your dataset, well, there you go. This will simply select the age and the salary in the matrix of features, and this line will simply select, well, the dependent variable in a nice 1D vector. All right, so there you go. That was the reason why I said it was so easy. You only had to change the name of the dataset here, social network ads.csv. Okay, and actually speaking of the dataset, now that we have the code to import it, well, let's not forget to upload it in the notebook, because in this same tutorial we will actually run these first cells. But before, let's make sure to finish implementing them. So here we're connecting to a runtime to enable file browsing, and in a second, there you go, we should have the upload button. So now we're going to click it to find our whole machine learning A to Z folder, and we're going to go inside. Then we're going to go to part 3 classification, then section 14 logistic regression, Python, and we're going to select our social network ads dataset. It is exactly the same with, of course, the age here, the estimated salary, and the purchase columns. There we go. Let's click open. It is going to upload it in our notebook, as we can see here. There you go. Perfect. We have it. So now we're ready to import it. But first, I want to finish the implementation of this data preprocessing phase. So let's move on here to the next step, splitting the dataset into the training set and test set. And here, do we have anything to change? Well, there you go again. Of course, no, it is not compulsory to change anything here. This will automatically create your training set and the test set out of the whole dataset. The whole dataset composed of the matrix of features X and the dependent variable vector Y. We're going to do some print, right, to show you everything, because then, the next step is to apply feature scaling. And before we get to this, well, I just would like to change something here, but again, that was absolutely not necessary. You could totally leave it like that, but I just want to change the test size, because since actually we have 400 observations in total, we have 400 customers in this dataset. Well, if we choose a test size of 0.25, it will be nice, because we will have actually 300 customers in the training set and 100 customers in the test set, right? We will have nice round numbers. So just exceptionally here, I usually recommend indeed 0.2 as a test size, but 0.25 is actually totally fine. You will see that we will totally be able to train our logistic regression model and the future classification models on this dataset with 300 observations in the training set, okay? So 0.25 is totally fine. We will have a nice training set of 300 customers and one nice test set of 100 customers. So there you go. Now we can move on to the next step, feature scaling, okay? All right, so first of all, let me explain the why. Why do we have to apply feature scaling here? Well, that's very simple. It is actually not required for logistic regression. However, still applying it will improve the training performance, and therefore it will also improve the final predictions. So you have to understand that for some models like SVR, feature scaling is an absolute necessity. However, for other models like logistic regression, it is not a necessity. However, still applying it will improve the training performance and therefore the final predictions. So that's the why we're applying it, but you can totally implement the same without feature scaling. All right, so now that we covered the why, let's proceed to the how. How are we going to implement feature scaling here? Well, there is nothing more simple thanks to our data preprocessing toolkit, which I've prepared here. And if you haven't, well, grab it in part 1, data preprocessing. And now in our toolkit, we're going to scroll down to the bottom to find that feature scaling tool, which is actually the last one. All right, here it is. That's feature scaling. So here we go. Let's grab it. You just have to grab the first cell implementing the tool. And now let's go back to our logistic regression implementation. Let's create a new code cell here for feature scaling and let's paste it right inside. All right, and now the last step that you had to do was to figure out what to replace here in this feature scaling implementation. Well, here that's super easy. We simply want to, feature scale all the features. We want to scale all the features. We want to scale age and salary. And of course, we don't have to scale the dependent variable purchased because its values are 0 and 1 and therefore are already in the range of values we want. So all good with this. So basically, we're only going to scale these two features, age and estimated salary. And therefore, here what we just had to do, as a replacement, was just to remove that selection of the indexes here. Here we selected all the indexes starting from 3. But this time we don't have to do anything. We can just scale the whole matrix of features. So I'm just removing here the index selections and there you go. We'll be ready to feature scale both our training set and our test set. And I remind that this is absolutely compulsory to do this after splitting the dataset into the training set and test set in order to avoid information leakage from the test set. All right, so there you go, my friends. That was what you needed to do for data preprocessing. Congratulations if you got the same thing. Don't worry about that test size. This is just for the form, but there you go. This was simply what you had to do. All right, so now we're gonna do a few prints to actually see the before and after feature scaling. So what I'm gonna do is right after this code cell splitting the dataset into the training set and test set, I'm going to make 4 prints just to show you. If you don't need to look at that, well, feel free not to include these new code cells. But what I want to do is print first X train, then I would like to print Y train. So here, Y train. Then next one, I would like to print X test. And finally, I would like to print, well, Y test. Okay? So that, and after feature scaling, however, we will just, print 2 cells because we actually don't apply feature scaling to Y, and therefore we'll just print first, well, X train again, and second X test, right? Because these will be the only sets of data that will be changed. All right, perfect. So now let's execute everything. We have the data set, all good. So let's do this, starting by importing the libraries. Good. Now importing the dataset. Great. Now splitting the dataset into the training set and the test set. There we go. All right. Now let's print xtrain and see what it looks like. All right. So let's scroll down a bit. All right. So that's xtrain with first the column of the age, the age feature, and second the column of the estimated salary feature. All right. And of course we have 300 observations in this training set. You don't have to count them, but there you go. We have many of them. All right, so now let's print yTrain. It's just to have a look at what we create, this is not compulsory. So that's yTrain with all the purchased decisions on the previous SUVs. 0 means that the customer did not buy any SUV, and 1 means yes, the customer bought a previous SUV. And now xtest, scroll down a bit, right, xtest, so same, it contains 100 observations corresponding to 100 customers, and for each of them their age and their estimated salary. And since xtest is actually supposed to be some new data in production, well, we're actually going to suppose that xtest is actually the set of customers who purchased, yes or no, the new SUV. We're going to pretend that xtest is actually some data when we deploy our model in production, so that we can evaluate it on the new observations, meaning on the new customers buying, yes or no, that new SUV. All right, it's more fun if we imagine xtest this way, because it is indeed supposed to be some new observations. And now ytest, let's see. All right, and ytest contains, of course, all the purchased decisions of the customers in this test set, meaning whether or not they bought the new SUV. All right, perfect. So now let's apply feature scaling and let's see how xtrain and xtest are transformed. All right, so let's do this. Let's play. And now let's print xtrain. All right, so now we have some scaled values between, -2 and +3. This one is 2.06, -1.7. Anyway, it should be somewhere between -3 and +3. Okay, but now we can clearly see that we have both the two features in the same range. The transformed age and the transformed estimated salary are now indeed in the same range. And that's exactly what we're supposed to get with feature scaling. All right, so now let's scroll down to print xtest, and the same, we get the two features age and salary taking values in the same range between somewhere around -3 and +3. So this will improve the training performance of the logistic regression model. Well, for the training set, of course, only for the training set, but then when we will deploy our model to predict whether the customers of the test set bought, yes or no, the new SUV, well, we will have indeed to apply the predict method on these scaled values, otherwise the predictions will be nonsense, right? The predict method has to be called on a set of features with the same scale as the one that was applied during the training, okay? Perfect, so now we can move on to the next exciting step. I'm talking, of course, about the step where we build and train our logistic regression model on the training set. And we're going to do this, of course, with our best friend scikit-learn, which therefore leads you to a new exercise. I would like you to figure out on your own how you can build and train that logistic regression model using scikit-learn. And I encourage you to have a look at the API, the whole scikit-learn API, to find the class that allows us to build the logistic regression model. And then I'm sure that you will know which method to use to train this logistic regression model on the training set. So please try to do it on your own. And of course, we will implement the solution together in the next tutorial. And until then, enjoy machine learning.